Right, is it on? That is working, there you go. I'll turn the light off, don't worry. Do you guys need paper? There's paper here. Yeah. Right, okay, so this is our first lesson. If you can write that title down, Dimensions and Units. Oops. Yeah, everyone has paper? Yeah. There you go. Dimensions and Units. Can you all see okay? Yeah. Oh, I shouldn't have touched. There we go. Now, let's get started. I don't know how many of you know these words. Does anybody know what a dimension is? Yeah? How would you explain it? That is true. That's the meaning of dimension in English, like EAP, but it has a different meaning in, well, no, it could mean that in physics, but it has a different meaning when we use it with the word unit. So, well, maybe units is a bit easier. What are units in physics? Do we know units in physics? What are those? I'm sure you do. What are they? Can you give me some examples of units? Meters, yeah. What else have we got? Seconds, things like this, okay? So, what we're going to have a look at, so, it's not necessary for you to write everything down, okay? Because that's maybe too much writing. So, key information is what you need, okay? So, what is a unit? I don't even think you need to write this down because I think all of you already know what units are. Yeah, a unit is a reference system. It's how we measure something physical. Okay. Now, what you maybe do need to write down is what's a dimension, because I don't know if anyone knows what a dimension is. Does anyone want to try and tell me what a dimension is? No?
I know, but I can't explain.
I'll go on. Try. Come on. Yeah. Okay. Anyone want to try dimension? Any ideas? These are hard words to explain, huh? Yeah. So, when we talk about length, mass, and time, these are called fundamental dimensions. So in physics, we say length is a dimension, mass is a dimension, and time, that's a dimension. Okay. More precisely, these are called the fundamental dimensions. Now, nobody knew that, so this would be good information to write down. Length, mass, and time are called fundamental dimensions. Fundamental, what does that mean? What's another word for fundamental? Basic, yeah. Like foundation. Yeah. Okay, you got that? Yeah. So, for example, the meter is used for measuring length. Right? So, what is used to measure the dimension time? Seconds. And what is used to measure the dimension mass.
Kilograms.
Kilograms, yeah. Yeah.
Oh, sorry, I thought it was under units.
Huh?
Oh,
It's okay? Alright. Other dimensions exist and can be created from these basic three. So, for example, area. You know area? Area is length squared. Yeah? By the way, what might speed be?
distance over time.
Yeah, no, but dimension. Yeah, well, we don't call it distance, we call it, the dimension is called length. So, speed's dimension is length over time. Yeah? Area is length squared. What about volume? Length cubed. Yeah? What else could we have? Well, that's the main ones. Now, the word magnitude, well, actually, does anyone know what magnitude means? No? Yeah, what do you think it means? Magnitude? Nobody? Yeah, like amount. Yeah, like size. How much? So, the size, how much, of a unit is called the magnitude. Okay, so for example, if this is, well, okay, maybe not this. If this is 1 kilogram, we say the magnitude, the size of it is 1. That's how big it is. Yeah? So magnitude just means size, that's all. Now maybe you should write that word down. Magnitude means size. Oops. Okay. You got that? No problems? Yeah. Lots of new words already? Yeah. Yeah. Unit, fundamental dimension, and magnitude. That's important to start with. Okay. So let's continue. I know all of you use this system, the international system of units. You all use this. There are no Americans here, right? There's no Americans snuck into class, no? I didn't think so. So it's also called the metric system. It's the world's most widely used system. I think they use it in every country except, oh, let me see. I think there's 2 countries that don't use it. Let's check. America and, I know Canada use the metric system, don't they? I think so, yeah. Right, there looks like there's how many? 3 countries that don't use it. Yes. Who do you think they are? First one is America. Who else? Who don't use the who don't use the metric system? Who do not use the metric system? No, they use it. And the UK use it. They use both. So the 3 countries are America, Liberia, and Burma. They don't use the metric system. Everywhere else uses it. There's 7 basic units in the metric system, and you already said some of them. For example, the meter. What does the meter measure? It measures the dimension of length, and the symbol we use for the dimension of length is an L. Okay, so I think you should start writing these down. These are the 7 basic units for the metric system. Now let's see how many of the 7 you know. Everyone knows meter. What's next? Yeah. Kilogram. The kilogram, and what dimension does that measure? Mass. Second, and that measures the time dimension. All right. What else is there? That is a unit, but it's not a basic one. That's a unit, but it's not a basic one.
What?
Not a basic one. Not a basic one, actually. The amp. Yeah, and what does that measure? Does anyone know? Current. And what letter do you think we use for current? No, I, yeah. Okay. Next one. Anyone else know any more? Not voltage, actually. Not watts. Yeah, that's one of them. Before we get to that one is the Kelvin, and that measures temperature. We usually use theta for temperature because we have T for time. Okay. Yes, you said one, Kehan. We'll do that one in a minute. There's one more before that. Which one? No. 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 It's used a lot in chemistry. It's used for measuring amounts. Used a lot in chemistry. Mole. The mole. What does it measure? Not quite mass. It measures what's called the amount of substance. N. And then the last one here. Now, all these six we use on the course, but the seventh one we don't use. So not need to worry about the next one, the last one. It's called the candela. Now, I'm sure a lot of you have not heard of this. But Kei-Hong, you seem to have heard of this before. Do you know what it measures?
Light.
Yeah, what about light?
The strength of the light.
Like the strength of the light, yeah. Have you seen this before?
Yeah.
No? You've seen it before. It measures what's called the intensity of light. Who's seen candela before? No, yeah. Okay, do you all have that? Yeah? I see some writing. Okay. Continue? Yeah. Okay, so the first fact, if you have the same dimension, you can compare or equate. Now, I believe you already know this. So, for example, I can say something like 10 meters is more than 5 meters. True? Obviously, true. But what I can't do is I can't say 10 kilograms is more than 5 meters. It's wrong. Why is it wrong? It's the wrong unit, the wrong dimension. This is wrong. Yeah, wrong dimension. This is mass, and this one here is length. Not good. Okay. I could say something like 2 meters equals 1 meter plus 1 meter. Yes. That's fine. So that's what I mean when I say same dimension, you can compare or make equal, equate. Now, you probably already know that, so maybe you don't need to write that down. If they have the same dimension, you can add, subtract, multiply, and divide. So You can say 1 meter plus 1 meter, minus, multiply, or divide. That's fine. You can do that. If they have different dimension, you cannot add or subtract. So, no, you can't say 2 meters plus 1 kilogram, right? Very wrong. Very wrong, yeah. But what about if you had something like 1 kilogram divided by 2 seconds? Yes or no?
No. Yes.
Yes, no?
Yeah,
Yes, you can. If they're different dimensions, you can still multiply or divide. It's still possible if it's different dimension. Do you need to write anything down here, or is this something you already know? Well, I'll give you just few seconds if you want to make some notes. Maybe you'll learn something new. Okay. Don't worry if you miss something. I'm going to upload this to YouTube as well. Right. So, I'm going to give you 2 minutes. I want you to write these questions down and then tell me which ones are right and which ones are wrong. Okay, so write these down for your first example. Tell me which is right and which is wrong, which is allowed and which is not allowed. I forget how to do this. Right, do you nearly have them finished? Right, you all finished? Yep, okay. So let's have a look at the first one. 5 meters plus 2 meters. Yes or no?
Yes.
Yeah. 5 meters is bigger than 2 meters? Yeah. 2 hours is bigger than 1 kilogram? No. X equals 3 kilograms over 2 meters cubed? Yes. 5 meters plus 2 kilograms? No. And 5 meters times 2 kilograms?
Yes.
Yes, good, okay, good job. Right, now, this one is getting a little bit harder. For each of these, I want you to tell me the dimension. And I tell you that X has the dimension of length, M has the dimension of mass. That is, dimension of X equals L and dimension of M equals M. In physics, we use this symbol to mean dimension. So for example, if X equals 3 meters, okay, then we say the dimension of X is length. Okay. If I say T equals 5 hours, then the dimension of T equals time. Do you understand? Yeah. So here I tell you the dimension of x is length, and the dimension of m is mass. And I need you to tell me the dimension of w, a, v, and rho. I want these dimensions. Okay? I'll give you 2 minutes. See if you can figure this out, and then we'll do the answers. Whoops. I'm accidentally playing a video. I'm just trying to add something to the YouTube channel for you. YouTube. Oh, sorry. Right. Do you have this done? Yeah? The first one. Let me write them down for you. What did you get for the first one? It was w equals x plus y plus z. What's the dimension of w? Yeah, but y? Hmm? Yeah, the dimension of x is length. Right? What's the dimension of y? Y? Yeah, but why? Yeah, but why? Because you're adding them, they all have to be the same, right? So it means that this one also has to be length. Fine, okay, good. The next one? What's the dimension? Length squared, yeah. A equals xy, so the dimension of A is length squared. Because this is a length and this is a length. Yeah? Okay. The next one is... What's the C? What's the third one? It's called length cubed, yeah. Dimension of V is length cubed. Yeah. Okay. And then the last one, dimension of rho. What's the dimension of rho?
Mass over length.
Yeah, it's mass over length cubed. Yeah. Mass over length cubed. Yeah? Not so bad, huh? Okay. So now what I want you to do is tell me the units. So the same questions, give me the units as well. So this should only take you 20 seconds. Write the units down. There we go. All right, finished? Right. What's the first unit? Meter. Good. Second unit? Good. Third one? Good. And the fourth one? Say it again slowly. Kilograms. Yeah, we actually say it differently when it's over. How do you say this one? Yeah, kilograms per meter cubed. Yeah? Yeah, is that okay? Yeah. Alright, next. Density is our first formula, is a measure of mass per unit volume. So as a formula, density is mass over volume. I think some of you know this already. And we also have seen the dimension. We can write the dimension two ways though. We can write it as m over L cubed or ml minus 3. Now, which of the two ways is better? Or should I say, which way should we try to use? First or second? Or the same? No, the second. On this course, we must use this. We're not to use this. Okay? And the same goes with the units. We're not to use this, we should use this. So, try not to use the slash. It's like the standard. You know the way in English you have standard writing practices, like how to do a reference or how to do a quote, things like this. In physics we have something similar. We have a standard way to write the units nowadays. And the standard way to write the units is with the minus. Yeah, so it's like a writing rule. Do you know what I mean? Yeah. Okay, so you need to write this definition box down. Okay? You don't have to write the last part down. At least write this down. Okay? What's going on? This is my Christmas present. It's a Fit watch. I like it. It says I slept 6 hours last night. 6 hours, 12 minutes. Not long enough. Okay, you have that? Yeah. So actually I should ask you, this letter, is it an English letter? No. What language is it from? Not Latin, no. Nice try though. It is an old language like this though. Greek. Yeah, Greece. Yeah. Do you know your Greek letters? I'm sure you know some of them. What's this one?
Alpha.
Gamma? No. Delta? Yeah. No. Epsilon? Yeah. Iota? There's sigma. There's omega. Yeah. That's eta. Yeah. Kappa. You know. Anyways, don't worry. We'll learn them as we go. Okay. So for right now, you need to know this one. Rho. Yeah. Okay. Rho. Okay. Right. Alright. Next. Now we can use prefixes to make units bigger or smaller. For example, 1 kilogram is 1,000 grams, right? Or 1 kilometer is 1,000 meters. Okay, so 100 centimeters is 1 meter. You all know this. The common prefixes we use are, right, so the first one is giga. What letter is used for giga? G. How many zeros? Oh no.
1,124.
Nope. How many zeros?
2.
10 to the power of 2? No. 10 to the power of 3? No.
6. 1.
9, isn't it? 10 power 9. What's the name of this number in English? Billion. Billion with a B. Yeah, billion. Okay, next one. Under giga is mega. The letter? M. Mega. 10 power 6. And what is that in English? Million. Oh yeah, I had one engineering student in the exam today ask me, what does this, how many zeros in this word? It was like a million. I said, oh, I can't tell you that. So you're supposed to know these things, okay? Billion, million. Okay. What's next after mega? Kilo. What letter? Big or small? No, small. And you know it's small because I wrote it here earlier. Right? So kilo, small k, 10 to the 3,000. Yeah. Right, what's next? You're looking very confused at me. What's next after kilo? The small ones now. We don't actually use that. I think you might use that in chemistry though. Yeah. So what's after that one? C. Yeah. What's that called? Centi. Yeah. Centi, C, and what power? 10 power. Good man. 10 power minus 2. 0.01. You've never seen this before. Are you sure you've never seen this before? Centi? Like here? 100 centimeter equal 1 meter? Yeah, so you have seen it before. Huh? Say again? A different word to this.
Right?
Oh no, actually, maybe it has a related meaning because, yeah, I see what you're saying. You say 100 cents equals 1 euro. So, yeah, maybe CENT has the same root as CENTI.
Oh.
Yeah, maybe so. Maybe so, yeah. Okay, what's the next one? Milli. What letter? M. Small m. How big? Yeah, small. 10 power. Yeah. Oh, I forgot. In English, how do you say this number as a word? So, like, for example, this is a billion, a million, 1,000. What's this one? A single word. Do you? 100.
Yeah, 100.
And this one? 1,000. Yeah. What is what? Oh! I'm teaching you a new word. Good. So, look. What number is this? 10. What number is this? 10th. Yeah. Am I teaching you something new? Good, good. Right, so this one here is 100, and this one here is 1,000. Right? What's the next one? Is there one before? Yeah, yeah, micro. What letter? Oh no, because we just have M here. W, what? Like you, but not you. What's it called? Mu. 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 And 10 power. Yeah. And how would we read this? A bit. What English word could we call this? A millionth. Yeah. Yeah. And the last one that we will study. Very good. Nano, what letter? N. How big?
-9.
And we can also call it a billionth. Yeah. Yeah. Yep. Oh, there's many more. Many, many more. There's like Zeta and Zato and Yocto and Yotta and Pico and Pica and we actually skipped one, as Kayhan said. There's actually one that's in between kilo and centai. There's one that's called 10 to the minus 1, a tenth, and that's called a deci. DECI. Now, we don't use that in physics so much, actually. Interestingly, it's used more in chemistry. Huh? I don't think we skipped any others other than deci for in between.
Like between kilo and centai.
I think there's only one in between kilo and centai. Is there other ones?
Yeah, hecto, deca.
Oh, deca. Sorry, deca, which is 10 power 1. Yeah. And then what's the other one?
Hecto, 10 power 2.
Oh my goodness, I don't think I've ever seen that used in physics. I've seen deci and deca, but I don't think I've ever seen hecta. Yeah. Yeah, actually that would be very rare to see in physics. Maybe it's used in chemistry. Anyways, you got all that? Yeah? Okay. Next. So, I want to show you how to convert now. So before I start, I should tell you, whatever way you learned how to do this in high school, you probably learned it a bad way. Okay? So if you think you know how to do this, I don't really think you do. Or at least you don't do it the way I like it. Okay? So I'm going to show you the way I would like you to do these questions. Right? So I'll just write the question down again here. It is to convert 50 kilometers per hour first into meters per second. Okay, so if we can write this down, this is how I want you to do these questions, okay? So you start off by saying 50 kilometers per hour equals 50 kilometers over hours, okay? But this K here is called kilo. And how big is kilo? It's 1,000, isn't it? And how big is hour? 3,600 seconds. Okay, so the answer is whatever this divided by this is. Let me check. .9 meters per second. That's the answer. Yeah? Okay. I want you to write this down carefully, please. Write that down. Everything. All right. You got that? Got that? Not everyone. Oh, I have a new subscriber. Who's Yap? YAP. Oh, thank you for subscribing. How many subscribers have I got? 3,000? No. Subscribers. 377.
Yeah,
377. Soon I will get to 400. Okay, you got that? Okay, the next part is harder. Miles per hour. And I tell you that a mile is 1.61 kilometers. Okay, so let's have a look. Was it 50? Yeah, 50. Kilometers per hour equals 50 times 1,000 meters over hours. Right? But remember we said hours is... no, actually we leave hours because we want the answer in miles per hour. So, this guy is fine. The problem is this guy. We don't want meters. What do we want? We want miles. So what do we do? How can I change this? So actually, do you know what? I'm sorry. Let me just start over. So, yeah, let me just start over, sorry. 50 kilometers per hour. Okay, sorry. Now, what should we do first? No, actually, I think I'll leave it as kilometers. Any ideas? Now, watch this. This is what I do. Look. Here, I put 1.61, and here I put 1.61. Okay? Look. This and this cancel. So it's the same. Yeah? But, this here, what does this become? That becomes mile. Because I said 1.61 kilometer is a mile. So this equals 50 over 1.61 miles over hours. Yeah, and let me type that in. So that is 50 over 1.61. That's equal to 37.3 miles per hour. Now this is the way I want you to do these questions, okay? Write that down, I'll do some more. Got that? You want to see the question? Yeah. It said convert that into meters per second and then miles per hour. Yeah. Okay. Can I continue? Yeah? No? Yes? Okay. Right. Convert 50 centimeters squared into meters squared and then convert it back. Okay. Now, before I start, something to tell you. One sec. Okay. Let's say we're in maths class and I write x, y squared, okay? Do I mean x, x, y, y, or do I mean x, y, y? X, y, y. Yeah?
Yeah.
However, when I'm talking about units, okay, if I was to write something like centimeters squared, do I mean centi, meter, meter, or do I mean centi, meter, meter?
No.
Which do I mean? The top or the bottom?
No, no. Top.
I actually mean the top.
No.
Okay? In other words, in units, when I write that, I really mean this. Yeah? So, if I go back here, 50 centimeters squared really means 50 centi squared, meter squared. Really. But how big is centi? How big is centi? 0.01 squared meter squared. Okay? So this is equal to 50 times 0.0001 meter squared. Okay? 1, 2, 3, 4, 1, 2, 0.005 meter squared. Now, the way you did this in high school, was it like this? I think probably not. In high school. Right? Did you do it like this in high school? No. You probably did something like 1 meter is 100 centimeters and then this thing and that. Yeah. Okay. Which I don't like. Okay. I like this way. Yeah? What's wrong? What's wrong? Ah, English. What's wrong with this? Problem? No. You like it? Yeah, okay, good. Right. Write this down carefully and then what we'll do is we'll go backwards now. Okay. Right, you got that?
Yes.
Okay, let's continue now. Can I scroll down? Yeah. Okay. So now the question also said to go backwards. So 0.005 meters squared. Okay. 0.005 meters squared. And now I want to go to centimeters. So what can I do first? This seems harder. Any ideas? Divide by? That's the idea, yeah. So what you do is here you put centi squared and here you put centi squared. So this equals 0.005 centimeter squared, and here centi squared is 0.01 squared, right? And that, and that should equal 50 on the calculator, centimeter squared. Yeah, this is great. This is a much better way to do it. Because there's less thinking. Thinking is hard. Yeah, it sure is. Okay. You got that? Yeah, continue? Yeah. Okay, next. A large sphere of radius 2 meters. Do you know what a sphere is? The ball, basically, isn't it? Yeah. So, just in case you didn't know this, Now, actually, hang on. How can I draw 3 dimensions? Let's see. Oh, beautiful. Yeah. Okay. Sphere. Now, let's see who remembers their middle school. V equals 4 over 3. Oh. Pi r cubed, yeah. Pi. And A? Squared. Good. Okay, good. Good job. Right. So, a large sphere of radius 2 meters is to be covered in paint. It's painted. And you want the paint to be 2 millimeters. And the density of the paint is 0.5 gram per centimeter cube. How many liters of paint is needed, and what is the mass of the paint? So I'm going to paint this now. Put some paint on it. And if I show you here, I need the paint. The thickness, yeah. I want this to be 2 millimeters of paint on the outside. Do you understand? Yeah? My question is, how many liters of paint will I need? And what is the mass of the paint? Okay, so this is the last example. It's a little bit harder. I'll give you a few minutes and then I'll do the answer. Okay, see if you can get this. Oh, and the bad news is, this is what the exam question is like. Okay, the examples I did are too easy. This example is an exam type of question. Right, I'll give you 3 minutes. Yeah, 3 minutes. See if you can do this. Yeah. I think it's dark enough we need the light on, huh? Oh, yeah, okay. Yeah. Now, I'll give you a little hint, okay? There are 2 ways to do this. You can think about it like this: a small ball and a bigger ball, and you can get a difference. That's fine. But in physics, you're allowed to do this instead. You can think of it as how can I do this? Yeah, you can think about it like this as well. Nobody has a basketball, do they? I'll use my hand, okay. So this is the paint. And we can picture the paint is around the ball. In physics, you can imagine that you take the paint off and then you open it up and you have an area. Do you understand what I mean? It's like you can unroll it. Yeah. Now, in fact, it's a lot easier if you think about it like this, that you have the paint and you unroll it. Yeah? So, whatever way you want to do it is fine, but the second way is a little easier. Okay, try. Yeah. Oh, sorry. Do you have a calculator? No, okay.
No.
1415. Yeah. But if you have a calculator, that's better.
You can 2
No,
divided
no.
by 7.
Not on this course.
Why?
It's not accurate enough. Okay, just one or two more minutes, maybe just one more minute. I see some people trying it, some people struggling, some people thinking deeply about it. Of course you can. Have you got a calculator? Yeah, what do you mean? Like change it to a number? Yeah, in the physics exam, yeah. 1415. Yeah. Okay, we ready? Okay, alright. You think you can get it, Marwan?
Yeah.
Oh yeah, let's see if I can remember your names. Right, don't tell me. Son? Yeah. Peter? No. Is it Peter?
No.
Oh, what's the first letter? Hey. What's the first letter of your name?
G.
No, don't remember, sorry. Oh, Jason. Yeah, okay. Give me a hint. What's the first letter of your name? Oh, it's Min. Oh, of course. Yeah. Should have remembered that. Daniel? Daniel? No. I've forgotten his name. Ah. Okay, I knew it was a D. Okay. Right. Then Daniel. Okay, good. Harry. Marwan. Abdul. Yeah. Oh, good. Okay. Oh, give me the first letter. You're Peter. I knew there was a Peter somewhere. Kai Hong and Ali Abdul. Abdullah Abdul. Is that how we'll tell the difference? Abdullah and Abdul? Yeah? Can be that? Or would you? No, is there something else you prefer? Yeah, well I need to have a slightly different name because yeah. So Abdul. What is your surname? Abdullah.
No, I'm not.
Abdul Rahman and Abdul Ali. Okay, well we can go with that. Go Abdul Rahman and Abdul Ali. That will do, won't it? Okay, so when I see you tomorrow, I'll probably forget half your names again. But by next week, I should be okay. Right, are we ready to see? No! No, I think we're ready to see. Did you get finished, Marwan? No? Okay. You got stuck. Do you think you got, Jason? You think you got the answer? Yeah? Peter? No? You think you got it, Harry? You're not sure. Okay, let's have a look. Let's have a look. So, like I said, what you need to imagine is that you unroll it like this. Yeah? And here. Now, how thick is this? 2 millimeters. Yeah? And this here is the area, and it'll be the same as this area. Yeah? So the volume will equal 2 times 10 to the minus 3. That's this piece. Then multiply by this, which is 4 over 3 pi or... Oh, sorry. 4 pi or squared. Yeah? So that's 2, 4, 16, 32 pi 10 to the minus 3. Yeah? 2 times 4 times 4. So that's 0.032 pi, which equals... anyone have that? 0.1005. Yeah, 53. Yeah. Meters cubed.
How many numbers?
Yeah, we'll talk about that in a moment. Yeah, I haven't said that yet for it. Well, I should say it now. In the exam, your answer must be 3 significant figures. Like, for example, 1.23 or 0.0456. You must have 3. Okay? But your calculations must be at least 4. Okay, so you could do something like 0.1234 plus 0.1234 is 0.2468, and you make that 0.247. Okay, right. Now, I didn't say what's the volume. I said how many liters. Does anybody know the relationship between liters and meters? The relationship between liters and meter cubed. What is it? How many? 1 liter equals 1 meter cubed? No. 1,000 what? 1,000 liters is 1 meter cubed. Yes, that's it. Yeah, that's it. Yeah? So, if we go back here, how big is a meter cubed? How many liters? 1,000. So this will be 0.1005 times 1,000 liters, which is going to be 101 if you round it. Liters. That's how much paint we need.
Okay.
Yeah? But we're not finished, are we? Because the second part of my question was, and what is the mass? Yeah, how can we work that out? Well, we'll get to that now. Okay, before I continue, do you need to write this down, or do you have it? Can I continue, or do you need to write this down? Continue? Yeah, okay. So, we said the density is 0.5 grams per centimeter cubed. Yeah? Let me change that to kilograms per meter cubed. Okay? So, what will I need to put beside the gram? A kilo, yeah? And so I must put a kilo here. Yeah? Kilo, yeah? Do I want the centi? No. So I'll just take it out. Centi cubed, meter cubed. So this here, this here, I need to calculate. If you calculate it, you get 500 if you put this in. So that's 500 kilograms per meter cubed. Yeah? Okay. Now, what's the formula for density? Density is mass over volume. So what's mass equal to? Density multiply volume. Okay. So the mass will equal 500 times 0.1005, was it? Yeah. Which is roughly 50.1 or 0? Yeah, 50.25, so that's 50.3 kilograms. So the answer is we need about 101 litres of paint of mass 50.3 kilograms.
What's a free lift for the bike?
Not in the physics exam, no. They need to have a number answer in the exam. So we, and also the answer must be 1, 2, 3, 1, 2, 3 figures. Yeah. Yeah. Okay. Do you need to write this down? Probably. I think, did some of you get this one? Did any of you get 101? Oh, you got the second answer, 50.3, yeah. But not the 101. Yeah. What did you get?
I didn't switch it to...
you kept it as meters cubed?
Yeah.
Yeah, okay. All right. Does anyone need to write down the first part? Does anyone need to write down the second part? Probably. You got both parts? Yeah, in the first part. Yeah. You got the second part?
I think
a different way.
Yeah.
Question?
So what value of pi did you use?
I think I used on the calculator here 3.1415. Yeah. Got that? Yeah. Now, what I want you to do now is I want you to start your homework. If you get the questions finished now, great, no homework. So I'll give you, for the last 10 minutes, If you can go to Moodle and open up the workbook, there are 3 questions I want you to do for homework. Do you remember when I showed you on Moodle there was a link called Workbook? Yeah. Can you open that on your phone? Did everyone find it? Were they able to find it? It's under Physics, Books and Resources Workbook. It's near the bottom. I can help you find it if you're having trouble. You find it? Question? Yeah, that's fine. That's harder, but that's fine. The answer will be a little different. Yeah. Exactly. Yeah. Exactly. Yeah. Yeah. But in the exam, no, actually, the way I did it, they're happy with that. Yeah. But you're right, this is better. Yeah. But in the exam they don't mind. They prefer this way in the exam. Yeah. And that's common in physics. In maths class we do it this way. In physics class we do it this way. Yeah, maths class did it this way, and physics class did it this way. Yeah, good. Question 1, 2, 3. Yeah. Yep. The answers are here in the exams. So, like for example, you see here, it's Physics 0506, Semester 2, Version 2. So, you can go back and go down Semester 2, 0506. Version 2, and then it's question number A1, the first question. Yeah.
Don't cheat.
Yeah, don't cheat, yeah. He's a good student, leave him alone. Yeah, those 3, you can start now. You found them? Great, yeah, those 3 questions, yeah. Yeah, you got them, good. Good. Did you find them, Kyron? Yeah, good. Okay, those 3 questions, yeah. Did you find them? Yeah, those 3, yeah. Question? I can help, yeah. No? Okay. Oh yeah, and bring paper tomorrow, okay?
Okay.